Well, this problem reminds me of Dallas Buyers Club. That's what this problem was about, the AZT drug studies back in the 70s. The AZT drug studies, they basically thought that AZT was a drug that could help someone who's infected with HIV virus but has not yet developed AIDS. So here are our important words. They had 435 subjects take 500 milligrams of AZT each day. 435 people got a placebo. Let's double underline placebo. And 38 of the placebo subjects, 17 of the AZT developed AIDS. So what is it that this problem would like to know? Um, is the true proportion of those who developed AIDS really lower for the AZT patients? That's what we'd like to know. Does AZT work? So we've got two proportions going on here. We'll call the first one the proportion A. That will be our AZT group. And we'll have proportion P. That will be our placebo group. Those will be the proportions of those who actually developed AIDS. So we've got our parameters laid out. Let's write our hypothesis, our HO. If I take a look at what I want to do, I'm going to take since I expect this one to be bigger, the placebo group, I'm going to go proportion placebo minus proportion AZT equals 0. That would mean that there is no difference between those two groups. My alternative, what I hope is true, is that the placebo group minus the AZT group is actually larger. That would mean that a smaller proportion of AZT participants, patients we'll call them, developed AIDS. All right, so I've got everything laid out. I feel like I'm good to go. Let's start checking our assumptions. I'm going to take that and make that all a little bit smaller so that I have enough room to write here. So there I am. I think we can still read that okay. Let's talk assumptions. A and phantoms. We need to deal with random. Do we have random assignment here? It says they assigned them at random. So we'll say random assignment to treatments. There we go. Then we've got to check our normal condition. If we're checking our normal condition, we're checking for the placebo group, NP, which would be, so NP will be for our placebo group. Actually, that's the number of successes. In this case, success is actually developing AIDS, and we have 38 of them actually developed AIDS, which is indeed larger than 10. N1 minus P is going to be whatever we get when we take 435 minus 38. 435 minus 38 is certainly bigger than 10. For the AZT group, our NP, that's the number of successes, and again, it's kind of strange that success is developing AIDS. We have 17, bigger than 10. The number of people who did not develop AIDS is going to be, what do we have? 435 minus 17, bigger than 10. So that condition is satisfied. And our third condition, independence. Yes, all HIV patients could be considered to be greater than 870, which was how many volunteers we had total. I clumped them together. I think that's okay. Well, where are we next? Next, we've got to take a look at gathering all of our information. Let's take this. I'm going to take this part, my conditions, group them together like I did before, small size that a little bit so that I have more room to write. Um, so I've got all that together. Now let's talk about naming our procedure. We are going to do a 2-proportion z-test, and we are going to do that at the alpha equals 0.05 level. All right. Our z formula for that, we'll take a look at taking the proportion of our sample proportion of the placebo group who developed AIDS, the proportion of the AZT group that develop AIDS, subtract 0 because that's what our HO says, divide by, oh, do you remember this now? What do we have to do? We have to pool our data. So we're going to have to look at a combined proportion who developed AIDS, 1 minus that combined, over N for our placebo group. We'll have to combine here as well. Now remember, the reason that we do this combining is because if we were to assume that HO is true and that the true proportion of those who developed AIDS is somewhere in between the proportions that we had with AZT and without AZT. So let's calculate that combined proportion. If I'm going to look at that PC is going to equal the number of those who developed AIDS in both studies, 38 plus 17, and we would divide by the 435 in both of those. That pooled combination, that pooled proportion, whoops, where is it in my paperwork here? That pooled proportion comes out to 0.063. At the same time, I'm going to take a look at what p hat for my placebo group is. That's 38 out of 435. That comes to 0.087. And the proportion for my AZT group, 17 out of 435. Excuse me, equals 0.039. So this combined is something in between those two. In this case, a nice average of the two. So T, let's actually calculate this test statistic by plugging these numbers into that Z formula. What will I have here? I'll have 0.087 minus, minus 0.039 minus the null hypothesis of 0. And then we'll divide by, now we've got to use this pooled proportion here, 0.063 times 1 minus 0.063. 1 minus 0.063 is 0.936 over 435 plus, and as luck would have it, we're going to have exactly the same number over here, 0.936 over 435. When I calculate that, hopefully I've calculated it right in my notes, I come up with a 2.93 for my Z-score. Well, what does that mean to us? What that means to us is that let's get that p-value. What was the probability? What was the likelihood of these two groups being so different? What was the likelihood? So we take a look and we say, all right, if I were to consider the z-scores for this, I would have had a z-score of 0 if the two proportions were the same. I got a z-score of 2.93. What is the likelihood of getting a value like that or one more extreme? When I look that up on my z-chart, I came up with a p-value, that's a probability value, the probability of getting a difference as extreme as I got, of 0.0017. It's a pretty small probability. So now when it comes time to make my decision, I'm comparing that 0.0017 to the alpha level that was set up at the very beginning, and that alpha level again was a 0.05. I compare the two. This is definitely smaller, leading me to reject my null hypothesis. And this is what doctors in the 70s were thinking at the time. Since we rejected HO, the S in my statement, my test, stating my conclusion in context, what does that mean? Go back up and look and see what HO was. HO was that there was no difference. If there was truly no difference, and we're rejecting that, so our evidence suggests that there really is a difference between the proportion of patients developing AIDS, between the proportion of patients who developed AIDS between the two groups. And if you wished to take it a step further, the proportion is lower for the AZT group. For the AZT group. Wow. Okay, so walking through all of these steps, the biggest issue that people will likely have here is forgetting to pool their data. We could have certainly done this on a calculator. The part that we would have done on a calculator would have been what I have in red and black over here. The calculator automatically pools that for you. I hope that helped. Thanks. Bye.